Hello, and welcome back to another IB Math speedrun with me, Vince. So in this speedrun, we're going to go through the compound angle formulae and what they are. So let's jump right in. So if you do follow along the book, which is a path you might want to take, then the exercises in the book will lead you to discover the compound angle identities on your own. However, if you are not and you are following me, then I will simply teach you the compound angle identities right now. So the first one is for the compound angle identity sine x plus a. And this can be expressed as sine x cos a plus sine a cos x. So we can convert between these two. And similarly, sine x minus a is equal to sine x cos a minus sine a cos x. Okay, next for the cosine rules, we have cosine x plus a is equal to cosine x cosine a minus sine x sine a. And similarly, for the cosine x minus a, this is equal to cosine x cosine a plus sine x sine a. Finally, for the tangents, for tangent of x plus a, well, this is equal to tangent of x times the tangent of a over 1 minus the tangent of x tangent of a. And similarly, the tangent of x minus a sorry, it's lagging a bit there. Tangent of x minus a is equal to tangent of x tangent of x minus plus the tangent of a, actually. Okay, tangent of x minus the tangent of a over 1, I believe it's 1 plus the tangent of x tangent of a. Yeah, so those are the compound angle formula or identities, the compound angle identities. Okay, yep, that's all correct. So let us look at some questions now regarding all of this. So it's being slow. So firstly, we have given that sine a plus b is equal to sine a cosine b plus cosine a sine b, replace b with minus b to find the identity for sine a minus b. So we get that this is equal to sine a minus b is equal to sine a cosine minus b plus cosine a sine minus b. And so the thing is, there's actually well, I guess an identity, but sort of, where cosine of a negative number is also equal to just the cosine of the normal number, since the cosine graph is an even graph. If you remember from our lecture about, or our explanation about functions, the cosine graph is parallel across the x-axis. So this holds true. So therefore, this is equal to cosine b. What about sine minus b? Sine minus b will simply be equal to negative sine b, since the sine graph is an odd graph function. So we get sine a cosine b plus minus cosine a sine b. So that is the new function. Okay, next question. We need to, given the identity tangent theta is equal to sine theta divided by cosine theta, implies that tangent A plus B is equal to sine A plus B divided by cosine A plus B. Show the tangent formula. Okay, so we know that tangent A plus B is equal to the sine of A plus B over the cosine of A plus B. We need to show that the formula. So let's expand this. We know sine A plus B is equal to sine A times cosine B minus, plus sine B cosine A all over cosine A plus B is cosine A cosine B minus sine A sine B. So what is the next step here? So the next step is to divide both the top and bottom by, well, cosine A cosine B. So this is equal to tan A, since sine A cosine B over cosine A cosine B is equal to tangent A, plus tangent B, all over, well, cosine A cosine B over the same thing is 1, and then sine A sine B over the same thing is tan A tan B. So it's 1 minus tan A tan B. So that's how we prove it. And so the final part is to replace B with negative B to find the identity tan A minus B. Well, we know that this is equal to tan A plus tan of minus B. And it should be noted that the tangent of minus B is equal to the opposite, is equal to minus tan B, since I guess the tangent graph is odd. So we have tan A minus tan B. And then this is all over 1 minus tan A times tan negative B, which is equal to 1 minus tan A tan B. So this is equal to 1 plus tan A tan B. So that's how we prove those formulas. Next, we need to evaluate some expressions. So the first is tan 105, and the second technically, and the fourth one is cosine 75, cosine 15 plus sine 75, sine 15. Okay, tan 105 is the easy one. Well, actually no, I think the bottom one's easier, but tan 105, well, we need to think, what is this equal to? Well, 105 is equal to 60 plus 45, so we can get tan 60 plus 45, and we know this is equal to tan 60 plus tan 45 over 1 minus tan 60 tan 45. So tan 60 is root 3 plus tan 45 is 1 all over 1 minus tan 60 times tan 45, which is 1 minus root 3. So in order to rationalize this, let's multiply top and bottom by this. So we have root 3 plus 1 times root 3 minus 1 over, well, negative 2 really. Since this is 1 squared minus root 3 squared is negative 2. So we get 3. Oh, sorry, no, it should be times plus 1 up here. So we actually get root 3 plus 2 root 3 plus 1 over negative 2. So we get, what is this? This is negative 2 minus root 3, I think, is the final answer. Let's just check that. Oh yeah, I actually don't think I've made an error, and I can't see how. So I'm going to leave this as negative 2 minus root 3, but maybe I have. Anyways, on to the next one, which is cosine 75, cosine 15, plus sine 75, sine 15, and this is simply equal to cosine 90, because this is cosine 75 plus minus 15, actually, never mind, not 90. So this is equal to cosine of 60, which is equal to 1/2. So yeah, that one was much faster. So let's move on to the next one. So the next question is prove the following identities. And the first, we need to prove some identities. I'll just write them out. The first one is cotangent A plus B is equal to cotangent A, cotangent B, minus 1 over cotangent A plus cotangent B. So, well, we know this is equal to 1 over tan A plus B. So this is equal to effectively tan 1 minus tangent A, tangent B, all over tangent A plus tangent B. And we now need to convert this into cotangents? I mean, okay. Looks a bit off to me, but... If we... I think this is the wrong approach. I think what we should do is we should try and prove it earlier, like how we did... So we know that this is equal to cosine A plus B over sine A plus B. So this is equal to cosine A cosine B minus sine A sine B all over sine A cosine B plus sine B cosine A. So we need to make this 1 and these two cotangents, so we divide all of it by sine A sine B. So this is equal to cotangent A cotangent B minus 1 over cotangent B plus cotangent A. So yeah, that is the proof. Next, we need to prove that secant A plus tangent A is equal to 1 plus sine A over cosine A. Okay. I mean, is this not just obvious? This is equal to 1 over cosine A plus sine over cosine A. Sine A over cosine A. So this is just 1 plus sine A over cosine A. It's just an inherently obvious proof. Oh, there's a lot more. Okay, let's go. We have, what's the next one? We have secant squared theta plus cosecant squared theta is equal to secant squared theta times cosecant squared theta. Okay, this is a bit of an interesting one. So we have 1 over cosine squared theta plus 1 over sine squared theta. So we have, oh, okay, of course, so it's just sine squared theta plus cosine squared theta over cosine squared theta sine squared theta. But since we know sine squared theta plus cosine squared theta is equal to 1, it's simply equal to 1 over cosine squared theta sine squared theta, which is equal to sec squared theta times cosecant squared theta. So that was pretty much it. Next, we need to prove that cosecant x minus sine x is equal to cosine x times cotangent of x. What do we have here? 1 over sine x plus minus sine x. So we can technically so this is going to be cosine squared x over sine x. Oh, and that's it. So since if we multiply this here, this is 1 minus sine squared x over sine x. And this is equal to cosine squared x over sine x, which is equal to cosine x times cotangent x. So simple. Finally, we have secant squared plus theta plus tangent squared, secant theta plus tan theta is equal to cosine theta over 1 minus sine squared theta. No, 1 minus sine theta. So let's see what we can get here. This is 1 over cosine theta plus sine over cosine. So, okay, so it's clearly 1 plus sine theta over cosine theta. And so we need to convert this into that. I guess the simplest way is to just multiply both by 1 minus sine theta. So if we multiply 1 minus sine theta over 1 minus sine theta, then we get 1 minus sine theta, sine squared theta over cosine theta, this is equal to cosine squared theta over cosine theta times 1 minus sine squared theta. And so if we divide cosine from both top and bottom, we get cosine theta over 1 minus sine squared, 1 minus sine theta, not sine squared. That's just normal sine. Yeah. So finally, we have one last problem. So we need to express tangent of a plus b plus c in terms of tan a, tan b, and tan c. So how do we do that? Well, we know that this is equal to the tangent of a plus b plus the tangent of c, right? Tangent of a plus b plus c. So this is equal to the tangent of a plus b plus the tangent of c over 1 minus the tangent of a plus b times the tangent of c. So if we expand tan a plus b, we get tangent of a plus the tangent of b, plus the tangent of b over 1 minus tan a, tan b, plus tan c over 1 minus the tangent of a plus the tangent of b over 1 minus the tangent of a, tangent of b, times the tangent of c. So this is tan a, tan b, tan c actually, over 1 minus tan a, tan b. Is there any further way we can manipulate this? So this would be tan a plus tan b plus tan c minus tan a, tan b, tan c. Okay. So we have tan a, tan b, tan a plus tan b plus tan c minus tan a, tan b, tan c over 1 minus tan a, tan b over, and then we can convert this into that fraction again. So we have 1 minus tan a, tan b plus tan a, tan b, tan c. So is that correct of an expansion? Oh, but this is a plus sign. So actually this would be 1 minus tan a, tan b minus tan a, tan c minus tan b, tan c. So this is a very long fraction. But as you can see, we can simplify it into this monstrosity if it's so. So it's tan a plus tan b plus tan c minus tan a, tan b, tan c over 1 minus tan A tan B minus tan A tan C minus tan B tan C. So now we're given A, B, and C are acute, and tan A is equal to 1/2, tan B is equal to 1/5, and tan C is equal to 1A. Then we need to find A plus B plus C. And so we can plug it into this formula here. So we have 1/2 plus 1/5 plus 1/8 minus all of them multiplied together. So minus 1 over 16 times 5, 1 over 80, all over 1 minus tan A tan B. So that's 10 minus tan A tan C minus tan B tan C. So we need to evaluate this fraction and see what it gives. I guess let's put everything over 80. So we have 40. Let's think. We have 40 plus 16 plus 10 minus 1 over 80 minus 8 minus 5 minus 2. So what we get here is 40 plus 16 plus 10 minus 1. 65 divided by 80 minus 8. 80 minus 8 minus 5 minus 2 is equal to 1. Oh, they're equal to each other. So we have tan 1. Okay. If we know all of these are acute angles, that means that if we add 3 together, actually, are there 2 possible answers? Tan A, tan B, tan C, A plus B plus C. I think there should be 2 answers. Oh no, but they're acute. Is it possible? Because the other option is of course, them to add up to 200. I think there are two possibilities, actually. Actually, no, I don't think there are. So this should simply be equal to pi over 4. So A plus B plus C is equal to pi over 4. So yeah, we get that. And finally, if A, B, and C are the angles of a triangle, show that the sum of their tangents is equal to the product. What? How can A, B, and C be the angles of a triangle when if you add them up, you get pi over 4? Anyways, ignoring that, we need to prove more or less that tan A, I think we can just ignore the triangle part. It's equal to tan A plus tan B plus tan C. Maybe the triangle part is important. So they sum up, and so they also sum up to 180. So that's the thing. So A plus B plus C is equal to 180. So we can plug it into this formula here. If we know A, B, and C are 180, then the tangent of A plus B plus C, or the tangent of 180, which is equal to 0, should equal this. So this entire thing should equal, and there of course, this equals 0. And so therefore this top part, tan A plus tan B plus tan C minus tan A tan B tan C must equal 0. And so therefore the statement holds true, because we have tan A plus tan B plus tan C is equal to tan A times tan B times tan C. So the sum is equal to the product in the angles of a triangle. So that was all for the speedrun. I hope you enjoyed, and I hope to see you in the next one.